Number 8. Ricky, shush. It is geometric because the R is negative 2/3. Number 14. You guys can see A1, A2, A3, 4, 5. Because you've had tons of time to get ready. I've had it up here. I've announced it 3 times. The bell means in your seat, ready to go. Number 24. We have A1, A2, A3, A4, A5. The common ratio is 1/3, and from that information you can make an nth term formula. Now, what's a little bit weird about this nth term formula? Did you guys, most of you, write the left one or the right one? Yeah, well, a few of you did the right. How many of you guys did the left one, if you got it right? How many of you guys did the right one? So 6 people got this right? So I see spot checks in our future. Okay, so question. The majority of the people who were able to answer correctly this problem wrote the left one. How do you get from 81 times something to all of a sudden 243 times something? What disappears? The exponent. Whenever you have subtraction in the exponent, what does that denote? Whenever you have subtraction in an exponent, what does this always end up? Is that true or is that false? Does n minus 1 denote division? Doesn't it? Oh, I thought you guys would notice it. Exponent rules from a long time ago. Algebra 1, Algebra 2, and Precalc. If you have x to the a over x to the b, x to the a times x to the b, x to the a to the b. How do we simplify?
X to the a minus b.
Lucas. How do I do the top one?
X to the a minus b.
Yeah, x to the a minus b. Keep the base, subtract the exponents. How do I do the second one?
X to the a plus b.
X to the a plus b. How do I do the third
X
one?
to the ab.
Power to a power, you multiply. Why was it hard? Because they expected you to be able to go backwards. Now, technically, are both just as correct? Why am I showing you this idea? What if the multiple choice answer, Jade and Jason, make sure you're tracking. What if the multiple choice answer showed this one? Does that make sense? You might have that one and say, oh, I don't see the answer, but it's there. So how would you finish solving? Yeah, get rid of the denominator. And 81 times 3, what do you think that might be? Got it. Tricky, 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 but not impossible. Next one. Zip. Number 40. Final answer, the mouse is on A sub 7. The 7th term is 8,957,952. Come on, guys, get to class. That's good. Get to class. Bring them in.
Tear them to shreds, mister.
So then coming back. Senior something. No. 8,957,952. You guys can see the work as to how they found the R and how they plugged in chugged to the answer. Number 48. A sub n is equal to, the common ratio is negative. And if you guys notice terms with negatives, they go back and forth. Negative, positive, and so it matches with C, which went back and forth, back and forth. Number 62. Can I zoom in a little bit? I don't know if I need to. It's a little small though, I apologize. 62, you have sigma notation. There were a few different ways of doing this one. I would have probably made 5 my initial term. They decided to make it all weird. I would have made 5 my initial term, so I would have plugged this in just a little bit differently. They're trying to find S sub 41. Some of the first 41 terms. Because we're trying to understand the formula. But you could have checked it with your calculator. For sure, for sure. You could have had a sub 1 being 5, and you could have had 1 minus 3/5, all raised to the 41 power, all over 1 minus 3/5. That should have ended up to be the exact same. I think it's a lot simpler than what they did. The reason they got all stuck up is because this didn't perfectly match that formula that was in the box in our notes. And that's what I said was the dilemma, when the formula doesn't perfectly match what's in our notes. We get a little confused, and that's why I put parentheses around the sigma in the S sub n formula for geometric sequences. The final answer is 12.5. Number 78. Question: why is there an answer for the infinite sum? Oh, come on. You had to learn something from yesterday. Why is there an answer from the infinite sum? What approaches 0? The 2/3 to the n approaches 0, aka r is, what's that condition that has to be true for the infinite sum to exist? Less than 1. 2/3 is less than 1. David, what's the name of these ones where the infinite sum exists? Convergent. So it's a convergent series. We can plug into our a sub 1 over 1 minus r formula, and we get 27 at the end. Hey guys, number 78 is a great non-calculator question. Why? Because you need to know the formula. Not S sub n, S equals a1 over 1 minus r. It's a great question because you have to realize r is 2/3, so it does work, it's convergent. And how should you be able to do this math on your own? Some of you don't mind fractions, and so some of you would be like, hey, 1 minus 2/3 is what?
1/3.
So some of you can do 1 minus 2/3, and you're like, no big deal, that's just going to be 1/3. Multiplied by the reciprocal, and you're like, hey, that's 27. But some of us aren't that good at fractions. So is there another way to solve this without having to know all that fraction stuff? Kind of. I have a different trick though. The other trick is to say, ew, who's the denominator that we don't like that's stuck in things? Just the 3, right? The 2 we don't mind. The 3 is nasty. My trick from earlier on in the year, can't we just multiply top and bottom by 3? What do you get on top? What do you get on bottom when you distribute? 3 times 1 is? What's 3 times 2/3?
2.
That's cool. No fraction stuff to do. The fraction's gone, and I got rid of them. How? Multiplying top and bottom by the little guy who's messing me up. That would equal 27 also. Just figured if I was telling you guys about how this was a non-calculator question, I should make sure, depending on how your brain thinks, that you know how to solve it by hand. Both ways work. And, kiddos, we're done. Any questions on odds or a little bit more detail you need on evens? No? It's kind of a hard section. How'd you guys do number 91? Huh. Yeah. Call me on it. Good question. Wish you guys had asked it earlier. I did hit the wrong one, didn't I? We're in 9-3, right? 91 is a great question. I even took the time to ask someone yesterday if it was in the homework. I think that was you, right, Nadia? Thank you. Number 91. How'd you guys actually solve? It had an arbitrary unit. You guys notice that it had an arbitrary unit?
Doesn't 91 focus?
Oh, was it? I just have it written down, I think, as regular homework,
No,
don't I?
it's regular. I was on.
Oh, you were thinking 9.1. How do we do it? Start with the first one. What area is shown here? Come on, that's 75 area of the square. 27 squared. Good. How do you do that? 27 times 27, right? What happens if you cut the square into thirds?
It becomes
How long is this one, this one, this one?
9.
3 by 3. So I have 9, but I have 9 how many times?
Okay, how is it 3? It's 9 by 9.
Yeah, it would be.
Oh,
yeah,
I was
it's nine.
thinking 9 by 9, like 9 was a total. Sorry, you're totally right. I just wrote it wrong. Because 9 and 9 and 9 make 27. Thanks for double checking it, guys. So what's the area of each of the little squares?
3 and
And how many do I have?
9,
Right?
8.
I have 8 because one's missing in the middle. So then the total area, who has 27 squared? What is that?
I mean, it's written down on our homework papers. We just have to double check it with our calculator.
Oh.
Make sure we.
7?
720.
Oh, 729. So I said 2.9. I was like, whoa, that's small. What's 81 times 8?
648.
Okay.
That's what should we do?
Hey,
What would the
you
next
worked
one
on
be?
last night, right? Wait, we're trying to find the area of the black stuff, right? Not the white stuff.
The center square is then shaded. New squares are formed by dividing the original square into 9 squares. The center square is then shaded.
What did you
We're trying to find the area of the shaded group.
The center square is then shaded. If this process is repeated 3 more times to show the total area of the shade. Oh, I missed it. That's lame. Okay, so well, we do need to label stuff though, right? I was doing the area of the non-shaded region. Alright, cool. What's his area? 0. But his length is 27 by 27. What's his? Still 9 by 9, but we only have 1, so then we just have 81. Okay. What's the area of the next one? We have the 81, right?
That would be 3 by 3. That would be 9. 81 plus 9 is 9. It's 9.
Because 9 to 27 is 3, so these are all little baby 3 by 3s, right?
8.
So then we have 9, and 9 times 1, 2, 3, 4, 5, 6, 7, 8.
That would be 72.
Oh gosh, yeah, no.
Ooh.
This is gonna suck.
And then we're going to have 81 plus 72 plus.
Can't even see what
Well, think about it. Hold on. It was 27 by 27, then it was 9 by 9, then it was 3 by 3, right?
Oh, one and a half.
So now they're going to have little 1 by 1s. How many 1 by 1s?
81.
Not 81.
No.
They're gonna have less.
64.
We had 1 of these, right? Then we had 8 of these. So 8 to the 0, 8 to the 1, 8 to the 2. There's going to be 64 little 1 by 1s. But guys, do you see a pattern between the 81, the 72, and the 64?
Wait, why is that so? There's one.
There are going to be, if you think about it, there are 8 shaded squares. So we have the 1 big one, plus we have the 8 littles. So we had 1 square, then we had 8 little squares, then we're going to have 8 squared little squares. 8 squared is 64. What's the pattern between 72 and 81, 64 and 72? Doesn't 9 go into 81 9 times and 9 goes into 72 8 times? So wouldn't that be 8 ninths? Doesn't 8 go into 64 8 times and 8 go into 72 9 times? 8 ninths? So aren't we going to keep on going and going and going? Going down 8 ninths every time? Or the next number, you can think about it as, yeah, times 8 ninths, that would work. Why is this an actual practical idea? Has anybody ever seen something with this pattern before?
Tiles. Oh, maybe.
No? Okay, well hold on, let me get you guys taking notes. I need to actually search for it. I don't have a picture ready. We're coming back to this idea of why on earth that was important. Put your spiral away.
You didn't phrase it.
No, it's okay. I need to get your notes up first. Open up your notes. I actually have it in the video, but the video is really long, and so to be able to find it, I tried a couple times, and it was just taking forever. Let me go ahead and get notes open from yesterday. I want you guys to practice with the NCR formula. Well, I try to show you a practical example of that design we just saw and why it is so helpful. It's actually crucial. It was a game changer. projector remote anywhere.
Oh, wow.
Never mind. Now I can freeze it. Why? Fractals are pretty nifty, and I don't know, I wish we had more time in this class to go over the applications of math and not just the basic foundations to how to do it. We'll see if maybe one of these days we can fit it in. I need to double click the screen. Alright, the recorder is back, but for some reason, I think I'm like at the very end of your notes. We need to go back to where we were, which was Pascal's triangle. Alright, you guys are supposed to be trying to find NCRs, right? How'd you guys plug into the formula for 10 over 3?
10 over 7.
It's technically, ooh, that thickness is a little bit different. It's technically this, just in case if you didn't quite know how to relate the two. Remember, he's really just that. Then, yes. Caleb, are you being very exclamatory?
Yeah.
10 over, yep, that works. 7 times 3, yep. But how do we solve it? Come on, mental mathers. You did it by hand, right? Did you get 10, 9, 8, and then the 7 factorials cancel? And then you had 3 times 2 times 1. Did anybody reduce the 3 and the 9 to be 1 and 3 and the 2 and the 8 to be 1 and 4, and you got 120?
Well, that's what I would do.
That's supposed to be top 3 plus.
What's the other way? I guess the 2 and the 10 could be 1 and 5. Or you could do 720 over 6. You could have done that. What happened in letter C when you guys went ahead and solved? Yeah, didn't you just have this? Well, that's kind of lame. Isn't that just 1? Some of you were like, oh no, 0 factorial. But wait. What did we say 0 factorial equals? 1, right? 0 factorial is always defined just to be 1. And last but not least, this would have been 8C8. And when you solved 8 factorial over 8 minus 8 is 0 times 8, what happens on either end? Whether it's 7 with 0 or 8 with 8, you get 1 either way. So the cool thing is, if we were to take these combination things, sorry, real quick, any questions about plugging into NCR? I didn't mean to not take a moment to make sure we're okay. Okay. You guys were saying Pascal's triangle yesterday. And it was for a very good reason. I showed you my big extra credit Pascal's triangle, which was kind of sad and sloppy. But either way. How does Pascal's triangle relate to combinations? If we were to do, let's see. These are all little combinations, right guys? Guess what would happen if you went on to solve all of these? We already saw, didn't we? Oops, I didn't mean to do 3, I meant to do 4. Didn't we see on the other page that whenever you have a number with 0, aren't all of these just going to be 1, 1, 1? What's it going to be on the other side? 1, 1, 1. Right? Ooh, I didn't mean to. Thanks for pointing it out. I'm going to zoom in and erase them. Okay. What's going to happen on the insides? Did you guys notice when we were over here, did we actually have one with a 1? Oh, we didn't. If you were to do 2C1, 3C1, 4C1, guess what? It just ends up being 2 and 3 and 4. And then if we keep on going, we're just going to end up with Pascal's, which, can anyone help us out? We didn't explicitly say it yesterday. How does Pascal's actually work? We have 1s on either side. Come on, you guys know how Pascal's work, don't you? How's the 2 come about? 1 and 1 make 2, right? How's the 3 come about? 1 and 2 make 3, 2 and 1 make... How's the 4 come about? Good, 1 and 3 make 4. The 6, where's he come from? 3 and 3. The 4, 3 and 1. So without doing any of the combination-y things, guys, what would the next row be?
1, 5,
10, 5.
And what do these numbers symbolize in our question from this entire section, which was how do we expand binomials raised to higher powers? This one would be the coefficient for a plus, let me come over here so there's room, a plus b to the 0. The next row is going to be the expansion for a plus b to the 1. The next row, the expansion for a plus b to the 2. The next row, the expansion for a plus b to the 3. The next row, a plus b to the 4. The next row, a plus b to the 5. Now, do you guys see any a's or b's in this triangle at all, though? No. So this gives us the coefficients to go in front multiplied by a raised to powers and b raised to powers, which is why binomial theorem we want to think about those patterns of how a goes top down from the highest, counting down to the lowest, which is 0 power, and b counts up from the 0 power up to the highest. But maybe some of you who weren't tracking yesterday can look back at those numbers that we were getting here and realize how I was able to skip the whole process of finding the coefficients, and I got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And how we would make a plus b to the 5th power. So kiddos, try to follow the pattern, including the a's and the b's. How would we, if we were to add, from what we just saw in Pascal's triangle, how would we expand a plus b to the 5th? 1, no, the whole thing. 1, a to the 5th, plus 5, a to the 4th, times b to the 1st. A is counting down, b is counting up, plus 10, a to the b to the, a is counting down, b is counting up, plus b to the, if we were to keep going, plus a to the, b to the, so we have 1, 5, 10, 10, 5, what's left? 1, b to the, oh, this out is kind of out there. You see it? Do you see the pattern of how a counts down, b counts up? A counts down from 5 to the 5th power to the 0 power, b counts up from the 0 power to the 5th power. But once again, Pascal's is really cool for expanding, right guys? As long as n is small. Remember the dilemma from yesterday? What if they don't ask for the expansion of one of these first few? And even if it was like the 7th, maybe we could just do Pascal's a little bit longer. What if they asked us to jump? That's the question we're trying to answer today. What if they ask us to jump? Could we go down to the 21st row of Pascal's? Because it starts at 0, so we'd have to go down 0, past that, and then 20 more. And then could we write the entire huge expansion, which would have 21 terms total, and then go find the one with a to the 5th? I suppose. That doesn't sound fun. So what's something else that we could figure out? When we go to a plus b to the 20th, right? Where would a to the 5th appear? What would be the power of b? And what would be the n and the r for c? Wait. How did I get this thingamabob? Where did this come from? NCR, a to something, b to something? You guys see where I got them from? I'm trying to jump to a term. And to jump to a term, I don't want to build Pascal's triangle, even though it's cool and all. I want to be able to see, hey, what's the NCR that goes with the first term raised to a power and the second term raised to a power? Do you see it? Okay, I'm trying to jump to this term. Did you guys notice in Pascal's triangle, what do the powers of a and b always add up to? Yeah, 5 plus 0, 4 plus 1, 3 plus 2, 2 plus 3, 4 plus 1, and 5, they all add up to n, right? So question, if we know that we have a to the 5th, and we know that n is 20, what can we fill in b's spot? b is to the 15. Does anybody find a pattern? Look at your formula real quick. If we know that b is to the 15th power, what else can we plug in as 15? R is 15. And question, what do we know about n? 20. And if you're wondering how we filled in this information, we can come back to the formula one more time. If we're able to, let's get that turned off. If we're able to know one power, we should be able to find the other. If we're able to find the r power, that should connect with that r. And then n comes from the original. So let me go ahead and try to show you real quick in this formula how we can kind of put it all together. Okay? So, if we have n, and if we have r, and if we have a to the n minus r and b to the r, if we're able to fill in one power, we can fill in the other power, from which we can fill in the r. And where does that n come from? Now, why is that so cool? Did you guys have to go to the 20th row of Pascal's to solve? No. What do you have to do to solve? Plug in. And find? NCR. How? Using the formula that we just practiced. 20 minus 15 is? Uh-oh. Maybe I don't want to do this one. 15 factorial. This might not be super fun to do in our heads. We have 20 times 19 times 18 times, those are big numbers. Someone throw it in your calculator real quick, either using the NCR operator from your math probability or using factorials. NCR would probably be faster. We know that A is going to be to the 5th, B is going to be to the 15th. Nathan, I hear you saying it. Go ahead. Does that look good? We got to jump there without doing 20 rows, 21 rows technically of Pascal's. Let's see if I was right. This is the a sub 5th term. Ooh. That'd be the 20th row.
First.
Ah, yeah, but sorry, when the second term is 20. 15504? Alright, go team. Okay. Let's keep going though. Ooh, hey look, Pascal's. Even further. Keep going. Oh, you guys saw that where does n show up in each row?
In the middle.
You see where n shows up in each row, right? It's in the second term. There are tons of patterns in Pascal's triangle. So let's actually give you guys a chance to practice. So, if I want you to write the expansion of the expression x plus 1 cubed. Who's your a going to be? Some of you are still kind of like, huh? Who's your, remember, aren't we doing a plus b to the n?
Oh, X.
Okay, good. So we can say that a is equal to x, b is equal to 1, and what's 3? N. Careful, not r. R is the power that the 1 is being raised to as we work our way across. If you wanted to be snazzy, you could say, hold on, I've seen this like 5 times now. What are the numbers of the cubed row? 1, 3?
3, 1. 1, 3, 3, 1.
It's 1, 3, 3, 1. You guys are right. Okay, so 1, 3, 3, 1. And what goes along with those coefficients? We have little like pluses right here, right?
Yeah.
What goes with the 1?
A cubed.
A, or x, to the highest power, which is cubed. What's the 3 going to get with an x? No.
Oh,
X squared. Count down 1. The next 3? And then technically x to the 0. Why do we not write him anything to the 0 power is? Yeah. But what have we not technically put in yet? We did that. We did that. Yeah. 1 would be to the 0 power. Well, isn't that just, it doesn't matter. Then we have 1 to the first power, 1 to the second power, and then 1 to the third power. But when we simplify, what does it end up being? Yeah, x cubed plus 3x squared plus 3x plus 1. Does that work? Caleb?
May I get water?
Yes. So does it get any harder than that? And the answer is, yeah. So hold on, we still have quite a ways to go in our class and quite a few examples. This one, life just got more exciting.
Oh.
Now, I'm going to change things up just a little bit this time. I'm going to say x plus y to the n. You guys know why I'm doing that? I have a's and b's. So I can just see this guy as my first guy, right? This guy as my second guy? Wrong. I need to think of, ready? I need to think of negative 4b. Because if there's a subtraction, I need to think of it as adding a negative. Does that make sense, guys? So 3a is going to be my first term, negative 4b is going to be my second term, and what's my n? Yeah. I'm just going to start off the first one. That's it. Maybe the first. Because it's a subtraction, sorry. If you look in, it was a minus and I changed it to plus. So subtraction you can always change to adding a negative. You guys could do Pascal's if you want. Remember to stop at the one where a 5 shows up. Nope, there's a 2. Nope, there's a 3. Nope, there's a 4. Ah, there it is. I want this row, right? So I could go ahead and have my, I can zoom out just a little bit, my 1 and my 5 and my 10 and my 10 and my 5 and my 1. There we go.
Do you have to, you would raise 3 to the 5th, right?
Not just 3 to the
But
5th.
also to the 5, or to the A.
I would have to take that entire term and raise it to the 5th power.
But could you keep it like that, or would you have to actually raise 3 to the 5th power?
Struggle.
Or stick it to the man?
Yay! But you can use your calculator, don't worry. David. Yeah, let me do one more term. I think it's a little bit more confusing perhaps when the other one comes in. Because remember guys, for the next one, wouldn't 3a be to the 4th power?
Yeah.
But we have to bring in the negative 4b, right? Wouldn't we need negative 4b to be to the 1st power? No, because remember, the first term counts down, so the first term starts at the n equals 5, and then goes 4, 3, 2, 1, 0. What happens to the second term? It starts at to the 0. Good. It starts at to the 0. It's not there to begin with, and then it starts counting up to the first to the second. So go ahead and continue the pattern, kiddos, if you can. Go ahead and continue the pattern if you can. And I'm not going to continue the whole pattern right this second. Instead, I'm going to go ahead and show you how to simplify the first 2 terms. Just read the 99, 81, and 81. These 240. We'll check my math, but I think it's 1620 for the second one. Has anybody gotten there yet? 3 to 4 is 81, 81, 20. Wait, why is there a negative? Where'd that come from? Because, yeah, negative 4b is for the first, the negative stays. But what's going to be true? Why is there a plus on the next one?
Squared.
Yeah, 3 coming down to the 3rd power, negative 4b is squared all of a sudden, which means that's going to be a positive. Do you guys agree on my first 2? If you're wondering where I got 1620 from, it's 5 times 3 to the 4th times 4 to the 1st, and I just pulled the negative out in front from the negative 4. You have to put all those coefficients together, the 5 and the 3 to the 4th and the negative 4, which makes it minus 16. So even though you can still see in the work the 1, the 5, the 10, the 10, the 5, and the 1, question, are those the final coefficients? Nope, it's just one piece. I'm going to go ahead and finish. I have 3a squared, negative 4b cubed, 3a to the first, negative 4b to the fourth. Last but not least, negative 4b to the first. If you guys agree with my first two, keep it going. What's next?
Negative 4, 3, 2, 0.
Wait, negative. Uh-oh. It's supposed to be a positive, I think, right? 4, 3, 2, of them. Because it's a negative times a negative for the 4, it's being squared. 4, 3, 2, 0, and a is cubed and b is squared. What's the next term? It's going to be a minus.
Wait, so then why is the second one negative?
Yeah.
Because negative 4b, the square is a 1. Oh, I see.
To the first power, it remains a negative, right? But to the second power, a negative times a negative is that. So every time the negative is raised to an odd power, there will be a minus, and every time the negative is raised to an odd power, there will be a even power, positive, odd power. What's the next one ready for me? It's going to be a plus, right? 8820? Oh, sorry. 3840. AB to the 4th. And the last term, are we on the last one? Yeah. 64, right? No, way bigger than that. I apologize. 16, then 64, then 256.
64.
Then
It's 10, 40, 10, 24.
not too bad, right?
The hardest question is
Yeah, kind of. As long as you keep track of the negatives and the positives and then the other numbers that you put in. What kind of problem was this? What were the directions again? Expand. I was doing the whole thing. Oh, double check.
What is the last term supposed to be negative?
Oh, thanks. I didn't even check it. Good double check. Now we're good? Good. So it should be alternating, right? Positive, negative, positive, negative, positive, negative. But wait. These were expand. So that means we need the whole shebang. All the terms put together. So how is that different than find? Okay, if you don't like the n specified term, just change it to like the p. I don't know. I'm just making up something. Just change it to p. It doesn't matter. Just find that term. Find the ready. Just think I want the 8th term.
Oh.
What does the 8th term mean? Over here, the 8th term would have been first, second, third, fourth, fifth. It didn't even have 8 terms, so forget that. They want the 8th one counted over. Oh, that's a struggle.
Oh, wait, that would be, yeah.
Could we expand the whole shebang and then count over? Okay, that's the first, that's the second, that's the third.
Yeah.
We could. Would it be nicer if we could try to jump there?
Yeah.
Okay, so some of you guys said that's the formula, and I like that you actually made that jump. Somehow we want to try to fill in into this. And just to make things a little easier, instead of writing NCR, I'm going to do that nice little parenthesis. I don't know, I like plugging stuff into that nice little parenthesis notation instead. What on earth can we plug into the 8th term? Well, hold on. Does anybody know anything we can plug in besides the 4x and the 3y?
They give you
They give you n. So n is equal to, right? I changed that other. N in the formula is always the powers being raised to, right? So we can put that straight in right away. 8th term, as we count over the terms, 4x is going down and 3y is going up. Which one sounds easier for us to figure out? The 4x, how far it's gone down after 8 terms, or the 3y, how much it's gone up after 8 terms?
Going up.
Okay. Question. How many terms are there total if it's raised to the 9th power? There are 10 terms. If you square a binomial, aren't there 3 is a trinomial, right? When you FOIL, there's usually a trinomial left over as long as the powers are nice. So this is 2 terms from the end. So at the very, very end, 3y is going to get raised to what?
9.
The 9th. So if we're 2 terms away from that, what's 3y being raised to? The 7th. You leave it that way. There are 10 terms total. The second term will end at the highest power. 3y at the very 10th term will be to the 9th power. The 9th term it'll be to the 8th power. The 7th term it'll get raised to the 7th power.
That adds up to 9. That's 2.
And then Ricky's trying to help us finish it, and we're really close to being able to finish it. But once again, if you guys are like, what's going on? This had how many terms total since it was raised to the 5th power? No, 1, 2, 3, 4, 5, 6 terms, right? The 6th term, b was being raised to the 5th power. The 5th term, it was being raised to the 4th. The 4th term, it was being raised to the 3rd. So we did that same idea with our problem right here and said, hey, well, if there are 10 terms total, the 8th term is 2 spots back from that. So if we say that 9 is where that second term will end, go back 2 from 9, we're at 7. And Ricky just said, hey, wait a minute, these two have to add up to be 9, don't they? So that'll be 2. And questions, anyone remember what goes in this box?
R.
R. 7. So we have NC 7, 4x squared, 3y to the 7th. Now guys, you would have to simplify, right? But now is it easy once we have the formula? Hopefully not too bad. Will anything else get trickier in homework? That's basically the trickiest, unless you see, that's not too tricky. Oh, I didn't even give you the trickiest kind, that's okay. There's one other tricky kind you'll see in homework and we'll see how you do on it. But otherwise this one, if you think about it, is really, really similar to what we just did. Think Pascal, think the binomial theorem. Sorry. Bye guys, happy Friday. I know, I didn't have any good chances. Homework due on Monday, 9-5. Test is coming soon on Wednesday.
What's that? 9-3? Okay, can do.
9-3 and 9-5, yay! Happy weekend.
Wait, test got